Here we go. We have a question 01 knapsack. So this is one of the three knapsack problems that we have in DP. So you have given weights and values of items and put these items in a knapsack of capacity W to get the maximum total value in a knapsack. Note, we can only we have only one quantity of each item. In other words, we have given two arrays value and weight, which represents the values and weights associated with items respectively. Also given an integer w which represent knapsack capacity. We have to find out the maximum sum values subset of value array such that sum of the weights of the corresponding subset is smaller than or equal to w. You cannot break an item, either pick the complete item or don't pick the item. So what it means is 01 knapsack signify 0 means we are not taking an element, 1 means we are taking an element, and we have to take the complete element, we cannot break it. So we have an element, its value is 1 and its weight is 4, and we have a back capacity of 4. So if we pick this, its capacity is 4, so our back capacity is higher than or equal to the this item weight, so we can surely pick this. So if we pick this item, its weight is 1, so we have a item of value w, value of value 1. So if you pick this item, we have a value 1. So next item we have its weight is 5, so we cannot pick this. Next item we have its weight is 1 and its value is 3, so this is more valuable, so we can pick this item or not pick this item. So we are getting our maximum answer by picking this item. So our maximum answer is 3. Choose the last item that weight 1 unit and holds a value of 3. In this case, we have a back capacity of 3, but item weight is 4, 5, 6. We cannot pick any item. So we can either pick the item or not pick the item. This is a common DP problem. So we will solve it using DP, and on the way we will optimize it. So let's first build the approach. We have 3 items here. So first we find our n. Here n is 3. So we have to build n cross capacity array. Here I am taking n plus 1 and capacity plus 1 array. 0, 1, 2, 3, then 0, 1, 2, 3, 4. Here it represent capacity and here it represent items. So if we have this cell represent we have item number 0, so we don't have any item, and back capacity is also 0, so value is 0 here. If we have this or any cell in this row, it represent we are not taking an element, so 0 represent we don't have any element, so in this row the value is 0. And in this column represent our capacity, back capacity is 0, so we are not able to pick any of the item. So here all values are 0. Let me fill the values. Now it's this cell turn. This cell represent we are taking first element, first item. First item is this, and our bag capacity is 1 in this case. So if we are taking this is value and this is weight. So if we are at this, we first have to check, are we able to pick this item by, is our bag capacity, in this case bag capacity is only 1 and item weight is 4, so we cannot pick this item. So the value is 0 here. Here the value is 0 because bag capacity is less than this item weight, so we cannot pick this item. Now here bag capacity is 4 and the item weight is also 4. That means we can pick this item. If we pick this item, our bag capacity is 4 and item weight is 4. Remaining weight is 0. If we pick this item, we are getting this value. So its value is 1. So we will store 1 here. Now item number 2 turn. We have this item. So our bag capacity is 1. Can we pick this item? No, we cannot pick this item. Our bag capacity is 2. Can we pick this item? No. Here no. Here answer is 0. But we will not take this element and take the previous element. Here what I mean is, if we have this item, we have an option. Either we can pick this item or we cannot pick this item. So here we are not able to pick this item, but if we pick all the remaining elements, so if we have picked the previous element, the answer is 1 here. So we have two elements here. So if we skip the current element, still we can make one value by taking previous element. So here the value is 1. Now this cell, and we have three items. It represent we are taking this element. So on every cell we have two choices. Either we can take the current item or we can skip the current item. We are at this cell, its capacity is 1 and item weight is also 1, means we can pick this item. So just pick this item. The value is 3 here. Now here bag capacity is 2. And item weight is 1, which means we can pick this item. So our bag capacity minus item weight. Bag capacity is 2, item weight is 1. We still have a space of 1. If we pick this item, we get value 3, but we have still one space left. So can we pick the previous item? So we just have to go previous elements. So we are taking this element and we have to check in the remaining elements. So we go in the previous row and check the remaining capacity. Remaining capacity is 1. So we have a cell this. So its value is 0. So here 0. Now this cell turn. We have this cell. This cell represent we have a bag capacity of 3 and item weight is 1. We have remaining capacity of 2. We are surely taking this element and we have some space left. So we can utilize this by picking some elements from the previous from remaining items. So just go in the previous row and find 2. 2, 2 here represent we have some capacity remaining in our bag and we are taking the elements before this. So that's why we have to take this element also. so its value is 0. Here same goes, we have 3 plus its capacity, back capacity is 4, item weight is 1, the remaining capacity is 3, so remaining capacity 3 from the previous element, so its value is 1. So here we have to return value from here. Here represents we are taking we are iterating all the elements and we have a back capacity of 4, so that's why we have to return value from here. So take let's talk about how we can find our take and not take element. So let's talk about first not take element. Like here, this is the important cell, because uh, our our item weight is 5, but we are still manage to take one value by not taking this element and by taking the previous elements. So if we not take this element, we will find our value from the remaining values. I minus 1 represent previous row, I represent current row, and j represent this capacity. So from the previous items we have to take the we have to take the capacity weight from the previous items. So we have a value. If we don't take this item, we have to take the value from this cell. So let's talk about take. We can only take this element if and only if our back capacity, means j, is greater than or equal to this item weight. So weight, so item represent here, so item minus 1. Why item minus 1? Because here we have one item, here we have second item, here we have third item, but this is array and it is zero based indexing, so we have to subtract minus 1. So that's why minus 1, we have to do minus 1. So if our back capacity is higher than or equal to this item weight, so we can take this element. So we have two variables, take or not take. Take means we are taking this element and getting the value I minus 1. I minus 1, I have already told you why we need to do I minus 1, because this is zero based indexing and here we have one base indexing. So that's why, plus we have still some capacity remaining, so we have to find the value from the remaining items. Item I minus 1, here, like suppose here I have to do I have to find item minus 1, means the remaining items. From the remaining items I have to pick some values. Our back capacity is j and item weight is wg I minus 1. So what it means is, from the previous items, if I have to take a back capacity minus current item weight, so this represent the remaining bag capacity, so from the previous items I can still take some values, which is, so from the previous items I can take uh, some values which is smaller than or equal to remaining back capacity. So like suppose in this cell, from the previous cells I can take this cell. So that's how we have to write. And on dp I and j, so this represent current item and current cell, we have to take the maximum between take value and not take value. So by doing this, we have a maximum capacity on every cell, and at the end we have to return dp of n and w, as I've told you. So that's how we will solve this question. Let's code this. Before this, I highly suggest you to write your code on your own first. So if you face any difficulty, then you can resume the video. So it's time to coding. So we have n, because n is not given here, and n is equal to weight and value. So it is same. You can take n from anywhere. Then we have dp, n plus 1 and w plus 1. For 0, I have a comment here. For capacity 0 or no known elements, we have nothing to put on, or no capacity, so 0. So that's why we don't need to iterate for 0. We can just start with one item. So this is item number 1, item number 2, item number 3. Next, J for current capacity. So it represents the back capacity. We have a maximum capacity of W. So we have to start from 1 till W. We have to take maximum items till now, but we are not able to pick this item. We pick the maximum answer which is available above these items. Means we are not taking the current item. So from the previous items, item minus 1, we have a back capacity of J. Back capacity of J. So we are not taking this current element. We have option, or we can take this element. So here I have a variable take, its value is 0, but we can only take. So check whether if we are able to pick this item. So first we have to write a check here. Back capacity either is this equal to or have to be greater than this item weight. So if this back capacity is greater than or equal to item weight, so we only then can pick this item. So we have a variable take. We take this item value plus from the previous items. From the previous items, we are taking the remaining item capacity. We are taking the minimum back capacity weight. So let me repeat again. So from the previous items, I have some back capacity remaining. So from the previous items, I can fulfill those capacity, fulfill this capacity. So now I have a variable take and not take. On the current cell, I have to find the maximum between take and not take. And at the end, we have to return dpn and w and represent. We are considering all the elements. Either we can take the element or not take this element, and we have a back capacity of w. So let's submit this. And in between, let's talk about time and space complexity. Here, our time complexity is n cross w and space complexity is n cross w. So here I have a question for you. Can we space optimize this? So if you carefully observe, we are we only need dpi minus 1, dpi minus 1, and here we are putting the value in the current row. So we required previous row and current row. So yes, we can optimize this. So let's space optimize this first. We have current array and previous array. Next we are iterating. So note take from the previous, because we have written dpi minus 1. Next take. So from if back capacity is greater, then take this value and find the remaining and fulfill the remaining back capacity in the previous items. Next, fill your value in the current cell. Then we are moving in the next row. So this row becomes previous, and we have to create a new row. At the end, we have to return the previous item, because we have initialized new array in the current. So that's why we have to get from previous. So that's how we will optimize this. But there is still a scope of improvement. We can still space optimize this. So what we need is, we have a previous array here and we have a previous array here. So here previous represents the remaining capacity. So let me first draw this. So suppose if we have to fill a value here, so what it signifies, either we can not take this element, so we take this previous element, or if we can take this element, so we have some value here, plus we have some back capacity remaining. So from the previous items some back capacity is still remaining. So suppose a cell here. So either we have to take the previous element or we have to take this element. So what we can do is, we can start from backwards. So if we have to take value from here, so either I can take still this value, because this value we have not initialized it. This row represent the previous row. So either we can take this value or we can take this value. So here represents as same as this. So either we can take this value, then we will fill this value, then we fill this value, means either we can either will not include this value. So this represents the previous row, and we are taking this element and we have some back capacity remaining. So that's how we will solve this by, and that's how we will optimize this by traversing backwards. So here I am traversing from 1 till w, but if we traverse from w till 1, then we don't require the previous array. So we have a current array and we have a for loop I, then we have j for loop. So we are traversing from backwards. So if we don't pick this element, then this cell is not updated till yet. So this cell represent the previous row. So we can take this. Then we have if back capacity is greater, then value and current cell. So its previous cell left hand side is not updated till yet, means its left hand side cells represents the previous row value. So that's why we can utilize this. Then we update the current cell. So here current cell represents the previous row, because it is not updated till yet, and now we are updating by considering or not considering this current item. At the end we will return w. Let's submit this. And here the space complexity is order of w and time complexity is n cross w. So this is the most optimized code. The code is given in the description box. So if you guys have any doubts, feel free to ask in the comment section. And thank you all for watching.